X equals 30 when y equals 2. Find y if x equals 5. If the variables vary directly, if the variables vary inversely. Now, there's two scenarios here. Directly is just taking the xy pair and matching it up with the other xy pair. But inverse is more complicated, okay? It means the x's are together. This is subscript 1, okay? And this is subscript 2. 1, 2. Now the y's are paired together, but their subscripts flip. 2, 1. Okay, just 1, 2, 2, 1. Okay, xy over xy is pretty easy, so we're going to put the 30 with the 2. We know that that's equal to the 5 over the x. Okay, or excuse me, x is 5, y is 9, so we would be finding y. Okay, so the product 2 times 5, that's going to be 10, and that's equal to 30 times y, so divide by 30. My second PRB that, and that would be 1/3. So y is equal to 1/3. Okay, if the variables vary inversely. Okay, now you got to go put subscripts. This is x1, y1, and this is y2, x2. Now you just got to concentrate here. So x1 is 30, x2 is 5, y2, we don't know y2, and then y1 is 2. Okay, so we cross multiply and divide. We find 30 times 2 and divide it by 5. The reason why you just multiply these because it's equal to 5 times y, and then we divide by 5, that'd be 12. Okay, y2 is equal to 12. Okay, now graphing. Graph the equation. Y equals 7 over x plus 1, and then after the fraction we have minus 2. Now this, anytime I have a fraction with a variable in the denominator, it's a rational function. Okay. So with rational functions we have asymptotes. Okay, you've got your horizontal asymptotes. Okay, the vertical asymptotes and the holes. Okay. Now horizontal asymptotes, that's what you do first because it's the easiest. Okay. Now this number here after the rational expression is known as a k value. Now when you do your horizontal asymptote, you need to remember that that's there. So horizontal asymptotes, you place your 7 over your x, you leave out the plus 1, put y equals 7 over x. Okay. Now if I would set that x into 200,000, 7 divided by 200,000 is approximately 0. So if x is on the bottom, we know that the expression, okay, as x gets higher and higher, okay, that says bottom, what I just wrote, bottom, write that down. That means it approaches 0. But you have to now minus your k value because that has the same effect to your y or horizontal asymptote. So it would equal negative 2. Okay. So on the y-axis you go to negative 2, okay, and then you make a line going straight across there. So y equals negative 2. Okay, now your vertical asymptote. Well, first thing you do, that's only one term, that's 2 terms. So the one term I know I can't factor, so I would keep the top just the way it is at 7, okay. Now x plus 2. Or x plus 1, excuse me, x plus 1. Could you factor that? I'm trying to factor it. No, you can't because GCF and DOPS, think about it. GCF would just be 1. Plus is not a DOPS, so we're keeping that in the same form, okay? So I just take the 1 off, put a parentheses, and we're just going to have x plus 1. Now the minus 2 also comes down with it. Now you take the x plus 1 and set it equal to 0. You don't have to worry about the minus 2 behind it. We've already accounted for the minus 2. So minus 1, x equals negative 1. Now does that stay a vertical asymptote or does it become a hole? Well, there's not an x plus 1 on top to cancel, so it's not a hole. So the holes are none. Okay. So you go to negative 1 on your x-axis and you make a line going up and down. Now, please label your asymptotes, okay? This would be x equals negative 1, Okay, so label your asymptotes just like that. Now, there's only one vertical asymptote. We need 2 points to the left and 2 points to the right. This is the only asymptote you have, so you're going left of -1, x equals -1, then right of x equals -1. So you're going to put 2 points for each. Okay. Okay, left of -1, we'll go -2, -3. Right of -1, well, don't pick 0, just go 1 and 2. Okay, so then we put these into the equation, put them into this last one here. So, and you got to remember the -2 is there. Okay, so let's talk about this. So let's just put our 7. We know we have a 7 on top, divided by, and we need to find what -2 plus 1 is, because I'm putting -2 in for the x. That's -1. But you got to remember to subtract the 2. Okay, so it's just 7 divided by -1, which is -7. And then -2, that's going to give you -9. Now you put -3 in for x. Okay, so -3 plus 1, -2. And then you got to remember that the -2 is there. Okay, so 7 divided by -2, click equals, and divide -2, you get -5.5. Okay, so you go -1, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, -3, -5.5, 1, 2, 3, 1, 2, 3, 4, 5, and then 5.5 is there. So again, it goes against both asymptotes. Okay. Now, right side, you're going to substitute -1 in for x. So I have 7 in the numerator, and I'll be putting 1 in for x. 1 plus 1 is 2. Okay. Putting 1 in for x, and then subtract 2. So it'd be 7 divided by 2 minus 2. Okay, 1.5. Now you put the 2 in for your x. Okay, so 7 divided by, now we're putting 2 in place of the x, so 2 plus 1, and that's 3 minus 2. So I go 7 divided by 3, and then minus 2, 0.33. So 1, 1.5, so 1, 1.5, and then up 1. Or excuse me, that was wrong. 1, 1.5, so it'll be 1, and then 1.5. Then 2, 0.33, okay? Okay, so it goes up, and it rolls against the asymptote, okay? It's an annoying problem, but yeah. So you need your HA, your VA, and then the holes. If there's none, there's none. Then, again, your coordinates, you mark where your vertical asymptote's at, right and left. Okay, for each rational function, identify the holes, the horizontal asymptotes, and vertical asymptotes. Okay, now, horizontal asymptotes is the same thing. Those are the ones that go across. You do not have a k value, so you can forget that. Okay, so I go y equals x over x. Okay, again, no k value, so you leave these out. See, if there's something added or subtracted beyond the fraction, that's a k value, but we don't have that here. Now we simplify this. If there's an x on top and bottom, well, we do some canceling, and that's a complete wipeout. So then y would equal 1. Okay. Now vertical asymptotes, you want to see if you can rewrite this. Okay. I mean, that's 2 terms, and that's 2 terms. But 1x plus 1, or x plus 1, that's 2 terms, but the GCF would be just 1. And there's no way that's a difference of perfect squares, okay? I mean, there's no minus, so that's going to stay the same. Take the 1 off and just put x plus 1 on top. Okay, x minus 1, okay? 2 terms, so GCF dots. One's your GCF. You have a minus, but you take the 1 off the front, and that's not a perfect square. Okay, so that would stay the same. Okay, now you're ready to take that factor in the denominator and find out what x value would make your denominator 0. That's your vertical asymptote, so that's 1. Now, does that stay a vertical asymptote or does it become a hole? Well, I don't have x minus 1 on top, I can't cancel, so that stays a vertical asymptote and there are no holes. Okay. Next problem, y equals x minus 2 divided by x second minus x minus 2. So horizontal asymptotes, okay? So y equals x over x to the second. Is there a k value behind it? Nope, there's not, so that's what I go with. So I'll cancel these. You cancel x to the first, and then you have x to the first right there. So that's 1 over x, because it's x to the first. We had a 1, we took 2 minus 1's 1, x minus to the first is x. Now, the x's did not wipe out, we have an x on bottom. So if the x is on the bottom, then the y asymptotes equal to 0. And it will stay 0 because there's no k value behind the fraction. Okay, now our vertical asymptote, okay? You got to try to factor these expressions. That's 2 terms and that's 3 terms. Okay, so 2 terms is GCF dots. Okay, no x, negative. You got so 1. You got a subtraction sign, but your x, there's no way that is. So that stays in its form. So x minus 2 stays. Now on the bottom, we have x to the second power minus x minus 12. So that's 3 terms. So it would be GCF and the t-chart. That better be factorable. 1's a GCF. Okay. Or that's negative 2, not negative 12, I'm sorry. It's negative 2. Okay, so 1 times negative 2 is negative 2, and that's a mismatch. It's a positive negative, and it adds to negative 1. Okay. 2 divided by 1 is 2. Add those, there's your negative 1 right there. Okay. Now your a is 1x to the second power. So we put in the positive 1, the negative 2, then x times x. And it's just 1's, which really you wouldn't divide, okay? You just take the 1's off the front, and we got x plus 1, x minus 2. So we need to replace that with this, because that's how I'm going to get my vertical asymptotes and my holes. Okay, so take the x plus 1, set that equal to 0. Take the x minus 2, set that equal to 0. So I subtract 1, I get negative 1. I add 2, I get 2. Now, are those going to stay on as vertical asymptotes or they become holes? Well, since we can cancel the x minus 2's, then that x minus 2 I just crossed out is no longer there. So this 2 that I got from the x minus 2 equals 0, crossed out of here, and now that's a hole in the graph. You still have a vertical asymptote at negative 1, but then 2 would be your hole. Okay, now we're going to simplify some expressions. Okay. Simplify x to the second minus 8x plus 15 over x second minus 25. Okay, so just this one fraction, so I'm going to use 3 lines to simplify it. Okay. On top we have 3 terms, put that in parentheses. On bottom you have 2. You need to rewrite those in factored form. Okay, if there's only one fraction, just use the 3 line rule. Okay, so we have x second minus 8x plus 15. So that's 3 terms, so it'd be GCF, and then the t table. Okay, 1's a GCF, 1 times 15 is 15. It's positive, so that's a match. Okay, so the match, negative, negative. It's got to add to negative 8, so it'll probably stay negative, negative. 15 divided by 1 is 15. That's negative 16. Doesn't work. 15 divided by 2 is a decimal. 15 divided by 3 is 5. So 3, 5. Okay, a equals 1x to the second power. So you put in your negative 3, your negative 5, then x times x, and then 1, 1. Now, I don't think those can be reduced because you just divide them by 1, so take the 1's off. And we're just going to rewrite that as x minus 3, x minus 5. So you replace this starting expression with these two parentheses. Okay? So replace this with x minus 3, x minus 5. Now, x to the second minus 25. That's two terms, so that would be GCF DOPS. Okay, there's no x, there's no negative 1, it'd be your GCF. Now, DOPS, take the 1 off the front of the x. That's cluttering up the problem. X seconds, x times x, 25 is 5 times 5, so yeah, x, 5, 5. So we're replacing this expression here with the x plus 5 and the x minus 5. Okay, now the x minus 5s can now be canceled, and that leaves us with these two parentheses as remainders. They're in the answer. Now you use this line in case you have to simplify any outer non-parentheses factors, but I don't have any, so that's a no-go. Don't need it. Okay, number 7. 3x to the second minus 10x minus. Now multiplication, you just combine that into a single fraction, and you're doing exactly what you're doing over here. Okay. Now, this is 3 terms. 1, 2, 3. Put it in parentheses. That's only 1 term, so you just bring that over and cross it out. This is 2 terms, goes in parentheses, and this is 3 terms. So that x does need to be brought over, but you don't factor it. Now on top, I got that 3x second minus 10x minus 8. So it's 3 terms, so it'd be GCF T chart. Okay, no, nope, and then 1 would be the GCF. So 3 times negative 8 is negative 24. So it's a mismatch. And it's a positive times a negative. It's got to add to negative 10. Okay. So 1 and 24, that's negative 23. 24 divided by 2 is 12. There's your negative 10. Okay. Now your A is 3x to the second power. So you don't go 1x, 1x. You go positive 2, negative 12. Okay. So x, and place the 3 in front. Now 3x minus 2 doesn't simplify. You can divide it by 1 if you want, okay? But 3 and 12 are both in row 3, okay? So we do this. That would stay the same, okay? But the other one simplifies. That's going to be 1x minus 4. Now you delete all of that, okay? You don't bring anything out. So we have 3x plus 2, and we have x minus 4. So that again, replace this with this on the top, okay? If that was on top, what I'm going to replace it with has to be on top. Okay, now on bottom we have 1x to the second minus 4x, okay? So that's 2 terms, so that's GCF DOPS. X on the end, yep, negative in front, nope. 1 and 4 is 1, okay? So you divide that by 1x. So it's going to be 1 and then x, and that's going to be negative 4, and those cancel, okay? So you bring down the GCF 1x, take the 1 off, okay? So I'm looking inside of the remainder parentheses for the dots. Take the 1 off, you got minus. X is not to the second power, so it can't be a perfect square. So x minus 4. So I'm replacing this with this. Okay, then 3x second plus 8x plus 4. Okay. That's 3 terms, so it'll be GCF table. Okay, 1 would be your greatest common factor. 3 times 4 is 12. That'd be positive 12, so that's a match. It has to add to positive 8, so it'll probably become double positive. So 12 divided by 1 is 12. That's negative 13. 12 divided by 2 is 6. That's negative 8. We need positive 8, so we stop dividing and just make the match positive. Okay, a equals 3x to the second power. So you put in your positive 2, your positive 6, and then 3x second goes xx. Then we place a 3 in front, okay? 3 and 2, just 1. But 3 and 6 is divisible by 3, so it's 1x plus 2. Take the 1 off the front of the x, cross all that out. So we're replacing this with this. 3x plus 2 and x plus 2. Okay, now the 3x plus 2's cancel, so do the x minus 4. Now we have a remainder parentheses of x plus 2. Now we do have some outside factors that are not parenthesized. You have an x and an x. Well, that's a dead wipeout, okay? Now, so they wipe out. But that's 1 that you put on top, then 1 over x plus 2. You need a numerator if you have a denominator. Okay, in the next problem, now we are adding the expressions, okay, not multiplying them, we are adding them. So we have x to the second over x to the second minus 2x minus 8 plus, so plus is a different ballgame. Plus, you have to get your common denominator, because right now the denominators do not match, okay? So you extend the lines, common denominator, and you need to put parentheses on top. That's 2 terms, parenthesize it. 2 terms, 3 terms, and 2 terms. Now, the parentheses on top you do not factor, just drop them. X second minus 4, and then x plus 2. Remember, this is all about the denominator. Now, to find the common denominator, we need to factor the denominator, okay? So x to the second minus 2x minus 8. So that's 3 terms. So that would be GCF and the t-chart. 1's a GCF. 1 times negative 8 is negative 8. So it's a mismatch. Positive, negative. 1, 8. It's got to add to negative 2. 8 divided by 2 is 4. That adds to negative 2. There you go. A is 1x to the second, so you know what's going to become of that. It's going to end up as just xx. Positive 2, negative 4. So xx, 1, 1. 1, again, these one, neither one of them are able to divide down, so just drop them. Take the 1's out the front, we replace this with x plus 2, x minus 4. Okay, now how about this x minus 4? Okay, it's 2 terms, so it'd be GCF DOPS if you can even do anything with it. Okay, no, 1's GCF. Got a subtraction sign. Take the 1 off the front. Now, x doesn't even have a power, so no. Okay, so we would keep that the same. That's a prime expression. Okay, so the common denominator, look in the denominator, you got the parentheses of x plus 2, the parentheses of x minus 4, and then another x minus 4, which we've already written down. So how many x plus 2's do you have in the bottom here? 1. How many here? You don't count that one on top. You have 0 here. So you need to take that 0 to an x plus 2. Okay, and you got to multiply it on top as well. Okay, you're going to multiply it on bottom. X minus 4 were 1, 1, so that's good. Okay. Now that you have your common denominator, you circle your denominator, and you got x minus 4 and x plus 2. Okay. Now you got to find these products, so I would make parentheses for each one and do your foiling. Okay, there's no multiplication to it. There's no times. You just put x to the second minus 4 with 1. Now over here you got to multiply it, so you got to FOIL. Okay, this is my FOIL box. So take 1x times 1x, 1x times 2, 2 times 1x, and 2 times 2. So that's 1x to the second, 2x, 2x, and 4. So, find everything you got. So you got 1, that'd be 4 now, that'd be 4. So 1x to the second plus 4x plus 4. Now you combine your like terms. You're not foiling anymore. X second's your highest, okay? Okay, because addition means we draw the blanks. So x second, 1 plus 1 is 2. X, you just got the 4. Then negative 4 plus 4 is 0. So if you get 0, get it out of there and just put 2x to the second plus 4x. If I wanted to be a real jerk, I'd make you do a GCF of 2x, bring that out, because you'd end up with x plus 2, which would cancel those, but I'm not. I'll have you stop there. Okay. Number 9. X second plus 3x plus, again, there's that plus sign. So plus, you got to get your common denominator and you space it. Multiplications when you extend it. Okay. So parentheses, that's 2 terms, 2 terms, 2 terms, and 2 terms. Now the tops you do not try to factor. Okay, you don't need to do that. But the bottoms, you need to try to factor them if you're going to find your common denominator. So x minus 3. There's nothing you can do with that. The GCF would be 1. And it's definitely not a difference of perfect squares. Take the 1 off the front. We would keep that in its same form of x minus 3. Okay, then x is second minus 9. That's 2 terms, so it'd be GCF, and then the difference of perfect squares. Now x on the end, negative 1's GCF, so you'd have a minus. You can take the 1 away, x times x, 3 times 3. So we replace this with this. Okay, common denominator, you got x minus 3, x plus 3, and then x minus 3 again. So x minus 3, I have 1 and 1, so I am good there. Okay, so check that. X plus 3, we have 0 and 1. Okay, so I need to go x plus 3. Okay, so now I have my common denominator set at x plus 3, x minus 3. Okay, now, got to find the insides. So this is the first fraction. You got to FOIL. This one we know, there's no multiplication operations. Okay, it's just x minus 2. But see on this other one, yeah, you're going to want to FOIL that. So you're going to do 1x to the second times 1x, 1x to the second times 3. Then 3x times 1x, and 3x times 3. Okay, so 1 times 1 is 1. Now an x second times another x would make it x to the third. And this would be 3x second. This would be 3, and then x second. And this would be 9x. So now we would have x to the third, then x, there'd be no constant here, so you got a 1. 3 plus 3 is 6. No, that does not go x to the fourth. When you're adding, it stays at the same power, then 9. So 1x to the third power plus 6x to the second plus 9x. Now you combine your like terms with the plus. So you got x third, x second, x, and constant. So x third, we got a 1, x second, 6, x, that'd be a 9 plus a 1 to make 10, and then negative 2. So you put that down here, 1x to the third plus 6x to the second plus 10x minus 2. Wrap it up. Okay. All right, now you're simplifying a complex fraction. This right here is known as your central division line. Okay, so since that's my central division line, what I'm going to do first is make a division sign down here. But I need to add these and add these. So you got 4 plus 4 over x. And then you got 1/3 plus 1 over x. Now, leave that an empty denominator. Now you have to get your common denominators, okay? Kind of like you're doing before. So you drop your 4's, okay, and your x. Now, for denominators, all we have is x, okay? So 0 and 1, okay? So we have to get them so they have 1. So I put an x here and x here. Now I have my common denominator. It's each x. And then I put my plus sign, and 4 times x is 4x plus 4. Please put a parentheses around that, okay? So that's your first fraction. In parentheses, please. No, it doesn't need to be factored, okay? Now, here, same thing. You have to get a common denominator to add these. So 1, 1, 3x. Now get the denominators to match. You have a 3 and an x. So 3, 1, 0. Okay, so we need a 3 here to match. X, you have 0, 1. Okay. Okay, so x times 3. Okay. Just put 3x, please. Okay. Then the plus. Now 1 times x would be 1x, but 1 times 3 would be 3. Put that in parentheses, and now we have our second fraction. Now remember, you switch that to multiplication, and you keep the first fraction the same, but you flip the second one. Okay, now the parentheses don't match, okay? I'm going to make 2 lines over there. The parentheses don't match, so they will stay in your answer, okay? Remember, multiplication, you combine it into 1. So 4x plus 4, and then 1x or x plus 3. Now, the outer factors, you have 3x over x. So these are both first powers. They cancel, and I have a remainder of 3 in the numerator. Okay, now we're solving equations. 1 over x equals 5 over x minus 4. Now, I just have one fraction on each side, so it's a proportion, okay? And we use cross products to solve it. We don't need a common denominator, okay? So I circle that, and I'm going to make an equals, because a times b, this product here is equal to c times d, okay? Okay, so a is 1, b is x minus 4, c is 5, d is x. Now over here, 5 times x is easy. That's just 5x. Okay, it'd just be 5x to 1x. Over here, you have to distribute 1 to 1x, 1 to negative 4. So it's going to be 1x and then negative 4. Now, I have in this equation, I have x only. Okay, because x, and there's another x also, but it's x only. So that's linear properties. There's no x second. So there's one answer. Take out your smaller x, so negative 4 equals 4x, then I divide by 4, and then negative 1 is equal to x. Okay, done. Next one, another proportion where we'll be using cross products. If there's just one fraction on each side, we are using cross products to solve it. Okay, so A times B, C times D. Now set up your quantities. Now you are multiplying. Put times dots between the parentheses because it's cross multiplication. So A is 2. B is x to the second plus 2. Okay. C is 1 and D is x plus 14. Now distribute 2 times 1x to the second. Well, 2 times 1 is 2 and it'd be 2x second. Then 2 times 2 is 4. Now on the other side, 1 times 1x would be 1x. And 1 times 14 is 14. Okay, now what do you have after those are done? After the cross products have been figured out, now we don't have x only. We have x to the second and x. You have to use your factoring properties. So there's 2 answers. So you need to clear one entire side. Clear the side without the x to the second. Okay? So I'd subtract 1x, but there's nothing with x over there. There's an x second, but that can't go with x. Then minus 14, that's a constant, and I have a 4 to put that under. Now you got equals 0. You go x second, x, constant. So x second, you got 2. X, you got your negative 1, and then 4 minus 14 is negative 10. So now there's your 3 terms. That'd be GCF and T-table. Okay, 1's your GCF. Okay. ABC. 2 times negative 10 is negative 20. So it's a mismatch. Positive, negative. It's got to add to negative 1. 120, that's negative 19. 20 divided by 2 is 10. Nope. 20 divided by 3 is a decimal. 20 divided by 4 is 5. So there you have it. Okay. So the A is 2x to the second power. So positive 4, negative 5. Remember, the x's at the end have to multiply to 2. Now they don't if you put the 2's, but when you divide down 2 and 4, that would be by 2. They'd both be in the 2 row. 2 and 5 just in the 1 row. So it's 1x plus 2. This would just drop down as the same. Take the 1 off the front. You got x plus 2, 2x minus 5. Now set those on your line, okay? And we're going to get the 2 answers with the F1, F2. So x plus 2 could equal 0. 2x minus 5 could equal 0. So minus 2, we get negative 2. Plus 5, we get 5. 5 divided by 2 is 2.5. You can also go 2.5 if you want. Okay, so those are your answers. Okay, number 13. 1 over x plus 1/4 equals 3 over x second. Now you got 3 ratios, so you can't use cross products. You have to use your common denominator to solve it. Okay? So, now we make the big lines, but it's going to be equal to a third line. Now, does any of this crap need parentheses? Okay? No, not a single one. Okay? They're all one term. So that's nice. No factoring for me. Common denominator, well, we have an outer x, a 4, and out. Don't put outer x second. X second is outer x. It just counts for 2 of them. So outer x, 1, 0, and 2. So we need them all to have 2. So I times by an x here, okay? I need 2 x's, so I times by 2 x's here. And then 4, 0, 1, 0. So we need a times 4, a times 4, a times 4, a times 4. Now, they all have 4x a second. Now, in an equals, you can cancel the denominators. You don't need those. Okay, so equals. Now, you set it up the same way as if you were doing a common denominator addition. But you can just multiply straight through. 1 times x is 1x. 1x times 4 is 4x. 1x times x can be 1x to the second. Okay. Then 3 times 4 is 12. Okay. So condense your equation. The 12's over here all by itself. Now you have x second and x over there. There's no constant. Okay. And you put the 1 first, then the 4. Okay. Okay, so it looks like now we have x second with x, okay? So you have to use your factoring properties to solve it. So there's 2 answers. We need to clear the side without, so minus 12 from there. So you got x second, x, constant, equals 0. So 1, 4, negative 12. So 3 terms, GCF, and the table. So 1 is your GCF, ABC. 1 times negative 12 is negative 12, so it's a mismatch. Positive times negative, it's got to add to positive 4. So 1 and 12, that's negative 11. 2 and 6, ooh, that adds to negative 4, but we can easily make it positive 4 by switching the signs to negative 2, positive 6. Now the a is 1x to the second, okay? So negative 2, positive 6. So x, 1, 1. Okay, you can't divide those down. You can't do anything with those, okay? Take the 1's off the front, and you've got x minus 2, x plus 6 equals 0. F1, F2. So x minus 2 could equal 0, or x plus 6 could equal 0. So you're going to add 2 to each side to get 2. Subtract 6 from each side to get negative 6. Okay, number 14. Again, this has an empty denominator. Don't put a 1, so you can't use cross products. You have to use it, get a common denominator for all 3 of them. Okay. Now, any parentheses right there be my only parentheses. Now, the top I just drop if it's in parentheses. This just drops, it's 1 term. Now, x plus 6, you really think you can factor a whole lot with that? It's 2 terms, so it'd be GCF, T table. So 1's a GCF, or excuse me, GCF DOPS, it's 2 terms. No, DOPS, no, okay. So it's just a prime expression, so we just bring that into its original form. Still need the parentheses. Common denominator, we got outer x, not to be confused with the parentheses x plus 6, and the third denominator is empty. So outer x, we have 1, 0. That doesn't count, that's in parentheses. That doesn't count, it's on top, so 0. And then 0 here. So we need them all to have 1. So an outer x, outer factors bring to the front is how I would do it. Okay. Okay, x plus 6, 0, 1, 0. So you need to get these to match. So you bring parentheses, you bring behind. Now, with that equal sign, we don't have to worry about the denominator. You don't have to put it down there. You cross it out, okay? You write your equals, and you have to find your products on top, okay? So 1 times x is 1x, 1 times 6 is 6, so it's 1x plus 6. X times x is easy, it's x to the second. Put the 1 in front, though. In this one, we take x times 1, 1x, and then we apply the distributed property. We take 1x to 1x, 1x to 6. So it's 1x second, that's 6x. Now, I combine your like terms, okay? And you see x to the seconds with x's, so pretty good idea that's factoring properties, two answers. But you got to combine things, okay, simplify it. So nothing can be done on that side. You got the 1x second and the 6x. Now on this side where there's two quantities, you'd start with your x second because that's the highest power, then your x, then your 6. So 1x is second, I got 1, and then 1x, and then 6. But a nice thing happens for me, a really nice thing, okay? We got to get equals 0 on factoring properties, okay? I don't have equals 0. Well, I don't know what side to clear because the x second's my highest exponent and they're equal, a 1 and a 1. Well, guess what they do? If they're equal on each side, the x's seconds are gone, okay? They leave the problem because there's not a smaller one to take out. Okay, so no longer, it's now x only. So now that's linear properties. There's only one answer to that. It goes from an x second x to an x only, okay? So you got 1x plus 6 equals 6x. So take out your smaller x. You get 6 equals 5x. Now divide each side by 5. That's going to be 1.2 or 1 1/5. It's up to you. Okay. All right, now story problems. So far I've made 30 out of 40 serves in tennis. How many consecutive serves do I need to make to raise my average to 80%? Average problem, okay? Average problem, you go right away to a proportion. Take your average 80%, put it over 100%. Now, they've made 30 out of 40. But that's not 80%. 30 out of 40 is 75%. So you add to you better add to the number made, but then that also automatically adds to the number I've attempted. Because if I made 30 out of 40, if I make my next one, that's 31, but then the 40 goes to 41 along with it. Okay? So you're using cross products to solve it. Okay? So A, B, C, D. Okay, so A, 30 plus X, B, 100, and this is times, not adding, C, 80, D, 40 plus X, okay. Okay, so distribute, okay, 100 times 30, that's going to be 3,000, and 100 times 1X, that's 100X. Okay. 80 times 40 is 3,200. 80 times 1x is 80x. Okay, now the parentheses have been done. I am x only, so I am using my linear properties. Okay, smaller x minus 80x. Okay, so now I have 3,000 plus 20x equals 3,200. Now, plus and times, you take out the plus. That's 200, so 20 times x equals 200. Then we divide by 20, and I get 10, so x equals 10. That's your answer, 10 serves. Okay, next. Two speed skaters travel for the same amount of time. The first speed skater travels a distance of 9 kilometers, while the second speed skater travels a distance of 8 kilometers. The first skater travels 4.38 kilometers per hour faster than the second. Find how long the skaters raced. This is a distance, rate, time, dirt table. So remember how your dirt table looks. It's got 2 rows, 3 columns. Now off to the side, we got skater 1 and skater 2. So distance, rate, remember rate means per, and then time. Okay, so the distance, well, we got 9 and 8. okay, 9.8. That's the kilometers they went. Now, per, well, I see per hour, but it says faster, so that's plus 4.38, okay? So that would be the one going the higher distance, plus 4.38. If you're wondering where to put that, it's always with the one of the higher distance. Now, we don't know this, so you can put R and R. Both terms are. We don't need two different variables. Now, the time, we know that the times are equal, and that time is distance over speed, okay? So, distance, okay, distance is 9, and the speed is R plus 4.38. The distance here is 8, and then the speed, the rate, that's R, okay. Actually, instead of D over S, put D over R, okay, that makes more sense. D over R, D divided by R, so you just take your distance divided by your rate, okay. Now set those equal to one another, and we solve a proportion. Now, you don't actually ever get a divide because you don't know what R is, okay? But the time is expressed as a distance over the rate, distance over rate, distance over rate, and the times are equal, so then the distance over the rates have to be equal. Okay, you're using cross products to solve, not the common denominator, okay? So, AB, CD. Okay, so A we have 9, B we have R, C we have 8, D we have R plus 4.38. Okay, so this is just one product, 9 times 1R, that would be 9R. Over here we distribute 8 to 1R and 8 to 4.38. So that's 8R, and 8 times 4.38 is 35 something. 35.04. Okay, you're solving for R instead of X, but it's R only, so you're using your linear properties. So take out the smaller r if there's two of them. Only one answer. So 1r equals 35.04. Now, you can divide by 1 if you want, but it's still 35.04. Now that's your rate. You got to find your time. Okay, you have found the rate. Now I take out this R right here and just put 35.04. Now I can find my time, which is the hours I need, by dividing the 8 by the 35.04. 0.23. That's kind of a weird answer, but it's right. Okay. Okay. You and your friends can mow 10 lawns in 4 hours working together. You have a riding mower, so you can mow twice as fast as your friend. How long will it take each of you to mow the 10 lawns working separately? So now we're not dealing with average, we're not dealing with distance, rate, time, we're dealing with units. Okay? So put lawns and hours. Hours is X, lawns is Y. So per. Lawns per hour. We don't know the lawns per hour, put a question mark. Just put M if you don't know it. Now, we don't necessarily need to go to the Y minus Y, X minus X, which is the M, the slope, because as we make our table, now I only need one of them because they're working together. Hours, lawns, okay? 0, but I don't have the rate of change, so I block that. And then 10 lawns, 4 hours. Now, if I sat on my butt and did 0 hours of work, 0 lawns get mowed, so that means it is a proportion, okay? And the proportion reads, well, how I title it is together and separate. My camera's about to die here.